Hello, everyone, and welcome to the Neural Implant Podcast. Today's guest is Yael Hanein. I think that's how you say it. She told me how, but it's difficult. She's from Israel. She's teaching as a professor in Tel Aviv University in Israel, and she's focusing on neuro-engineering and especially wearable electronics and also a little bit of bionic vision. So her research group is working on kind of, you could think about it like temporary tattoos, electrodes. So this has the advantage over wet electrodes because it can be smaller and it can go directly on the skin. They have a smaller resolution and and then also she's working on another company, Nano Retina from Rainbow Medical, and so really cool because she's an academician. She's an academician, professor, life, but also has done a lot of work with companies. So I really love this kind of stuff. I love this translational stuff going from bench to bedside. I think this is very important to do. So enjoy. Yael Hanein, pleasure to have you on the show. I don't think you just said it, but I don't think I said that absolutely correctly. But you are a professor at Tel Aviv University in Israel, professor of electrical engineering, but you also do startups. And, like any good Israeli, I guess, you found Electrodes, which kind of does wearable electrodes, but also are involved in Rainbow Medical with Nano Retina. So really cool stuff. I absolutely love this kind of work, spanning both academia and industry and kind of bridging those together. So first of all, thank you for coming on all the way from Israel. And so do you want to explain your work a little bit?
So generally we work in the field of neuro-engineering. And for many years, we were working on electrophysiology or electrophysiological tools as implantable devices. And more recently, almost the past 10 years, we started focusing on using those tools, but for skin applications. So devices that can monitor electrophysiology from the skin. So this is surface EMG, EEG, EOG, and many more.
Okay. So how does that work? I mean, you have the EEG, you have basically an electrode on the skin, and that picks up the electrical signal. And you're basically printing these on the skin, almost like a tattoo, right? And then those are dry electrodes versus the normal wet electrodes. What's the difference?
Right. So we don't print on the skin. We actually print on very soft substrates. And those are applied with very thin adhesive materials to the skin and basically can remain on the skin for a really, really long time. And exactly as you said, these are dry electrodes. So unlike the conventional silver chloride electrodes that demand the use of a gel, here we can apply the electrodes directly on the surface of the skin. And that really depends on the softness of the substrate. So that was a major thing that we had to deviate from the more conventional approach of using printing on Kapton or Mylar and other materials, and using some seriously soft materials so the substrate of the entire device can really conform with the skin.
So what are the advantages of, I mean, obviously you get a better connection, but the wet electrodes, I mean, they also have a good connection because, they're wet, so they can conform to everything. Is it comparable, I guess?
Well, it's comparable when you work in a lab environment, but once you try to use the electrodes outside the laboratory with a wireless system when a person is freely behaving, then it becomes an entirely different story. The gel electrodes are optimized for lab setting, and they work very, very well for pretty short durations because eventually they dry out, and it's a matter of hours, and they dry out. They have the wires, and they tend to move and introduce mechanical artifacts. The nice thing about the soft dry electrodes is that they don't dry out because there's nothing really to dry. And because of their very low impact, you can introduce small miniaturized microelectronics and basically use the system in a completely wireless, truly wireless, really allowing people just to move anywhere. Actually, one of the nice things about this technology when we started testing it was that conventionally, when you try to do electrophysiology, you look for the best spot in the lab and the best conditions. And here, actually going outside, sitting outside under a tree is the best place to do the recordings.
Why is that?
Well, because the system since it has no need for it's wireless, so it can be done anywhere. And when you're outside the lab, you don't have all the interferences that you have inside the lab. So working outside is just as good, and actually it's perfect.
Yeah, that's really cool.
For sports applications, for any situation that has been so far almost impossible for extended electrophysiological studies, now it's completely natural.
That's really cool. So you had mentioned, the wet electrodes, they're for short duration, and then the dry electrodes, they're long duration. What does that mean exactly?
So what do you mean by
like what does short and what does long mean?
So short could be anywhere from half an hour, 1 hour. It really depends on the technology, on the specific technology, because there are quite a lot of them and different uses. And long could be an entire night, 24 hours, even a couple of days. So now one of the things we do routinely now at Electrodes is to perform overnight recordings for sleep staging. In sleep staging, you want to do EEG and EOG and EMG over 8 hours. And so this is something that can be done without any problems.
Wow. Yeah, that's really cool. That's, many times longer. So that's, and if it can resist sweat too, like sport and movement, then that really does seem like a big advantage. Okay, so we talked about the what, but what do you actually use these electrodes for? What kind of data, what kind of information can you get out of them?
So the fundamental information is electrophysiological. So that could be EEG, EMG, EOG, of course, ECG. And the range of application is pretty wide. We've been testing it and we use it for several research applications and two major applications that the company is pursuing. So in research, we started with the first thing was for mapping facial expressions. And this is something that using conventional EMG, the wet electrode, is very, very problematic. The face has a lot of muscles, 43 different muscles. And if you want to monitor them with very high acuity, this is really, really problematic with conventional electrophysiology. With the dry electrodes, this has become very natural, and we could apply the electrodes, record the signals, but also do really nice signal processing and derive the exact location of the muscle. So what we can do now is actually characterize facial muscle activation in a manner that has been so far impossible, and looking at facial expressions is something that of huge interest for psychologists and psychiatrists, neurologists, and marketing people, many more. So this has been one example. We've been collaborating with colleagues using the electrodes for lie detection. This is relying on the issue of facial expressions. We've been working with colleagues on the issue of sleep and specifically doing sleep staging at the convenience of your own home. So presently, to do sleep staging, you need to go to a hospital and you need to sleep in a hospital bed. And this has many limitations. For some applications, there's also a need to do it multiple nights. So this is clearly not the greatest situation. So we've been working really, really hard on turning the technology into something that people can use at home and record overnight and obtain a full medically relevant sleep staging information. You mentioned sport, and so this is one big direction that we try to pursue within the as a commercial application. And there, what the electrophysiology gives us is the ability to monitor muscles, of course, during movement, but also to compare different muscles. So, for instance, when you want to study symmetry, the application of force during exercise, the balance in applying force, but also within the realm of sports application, of course, there's a big issue of preventing injuries, but also improving the fitness and quick rehabilitation. So this is several very, very important issues in sports applications.
Oh, that's really cool. So with traditional wet electrodes, usually the electrodes are, I don't know, the size of a coin, something like that, relatively large. But I'm assuming with yours, you can print it to much smaller
Right.
sizes. What kind of resolution can you get? And does this extra resolution help, or is it just kind of oversampling, measuring much of the same, location, something like that?
Yeah, this is a very important issue because we've been discussing the duration and the inconvenience of the gel electrodes, but actually the fact that we can make many smaller electrodes and use that information in a smart way means that we can obtain much more information than conventional surface EMG, for example. So the electrodes can be as small as 4 and 5 millimeters for many EMG applications, and that suffice to give really nice signal to noise ratios. And using large arrays, the largest we've been using so far were 16 electrodes. We can apply blind source separation algorithms, and from the data we can derive specific locations. And that has two implications. One, as I said, it allows us to find the source. So we can overcome crosstalk, which is a very big problem in surface electrophysiology. But the other very big benefit is that it negates the need to be very precise at positioning the electrodes. This is a very big issue. So, for instance, in sports applications, one of the limiting factors in using electrophysiology is that you really need to be very knowledgeable about physiology. You need to know where to put the electrodes. It has to be very precise. But when you have a lot of electrodes and you apply source separation procedures, it doesn't matter anymore. You can roughly place the electrodes, so any person with a minimum knowledge can place the electrodes, and then you can compensate for the inaccuracy in the position with the mathematics.
Yeah, that's really cool. Yeah, you can kind of after the fact tune it and make sure that it's a real expert can then look at the data from the comfort of their chair and
Exactly.
be able to find the best locations. Yeah, so you founded a company with this in Israel. So there was the whole book, Startup Nation. Talk about how great startups are in Israel. What's that like? And I guess before we get to that, what's I think you're the first Israeli researcher we've had on. What's academic life like in Israel? What's startup life like in Israel? How is it maybe different or the same compared to other places?
So the academic system in Israel is very much like the American one. So it's a tenure process, and you're very much independent, pretty much from the first day that you start your position. So unlike some of the European places and maybe some of the Asian countries, here the independence is built in and from day one. And you're expected to you start with a startup startup money for building your group, and then pretty much you're on your own, and you have to secure funding, very, very much like the American system. The difference, of course, is that the amount of funding is much smaller, and the availability of international students is also typically more limited. But generally, I can say that it's very, very similar, and I think it's a very good system. Again, it allows people when they're most creative to really work and flourish. The one other thing that characterizes Israel is that Israel is a very small country, and we always joke about it here that everybody knows everybody. And this is I didn't read the Startup Nation book, but I'm sure it must have been mentioned there. The fact that people, because everybody knows everybody, it's a very big asset. Because when I started or was looking to start Xtrodes, I was consulting with a lot of people, so I could ask people, and people are very forthcoming and trying to help. And everybody who ever had anything to do with building a company would be very happy to share their their success and their less successful moments. And so there are a lot of people around to learn from. You mentioned Rainbow Medical. So for me, that was a 10 years of amazing experience, not just because of developing an artificial retina. That was, of course, the biggest thing, but also while doing that, also to learn from very experienced people how to approach the idea of commercializing a technology. And so the beginning of Xtrodes was really about finding the right partners. And I found there was a good link with Ziv, who is the CEO of the company. And then slowly we found some more people and brought more people. And this is how it goes. It sounds very, very simple. It's a long process, because you need to find the right people, and you need to learn quite a lot of things. It took me several years to learn all these things, but the point is that these people are around; they're everywhere.
Yeah, that's really cool. It's almost like, I mean, before the episode, we were talking about, the population of Israel is 9 million. And so the COVID vaccinations have been very fast because of that. So it really is like almost like a city state a little bit, because it is kind of smaller and it is maybe more compact than, other places. So that's an interesting advantage to have. You don't have to fly for 6 hours to go, see whatever other expert in the field. Yeah, so let's talk about Xtrodes. What is the company? It's kind of this along this line of the wearables. What does it do? How was it founded, and why was it founded?
So it was. I'll start maybe with the last question. Why was it founded? Because it was a really nice. I think it's a really nice story, because we started this project as a purely academic project, which was how to resolve the problem of the wet electrodes. And we started working and improving the technology, and getting into the understanding of the different applications that we can use it. And when the first few papers came out, we started receiving a lot of interest. So people were basically knocking at our door, arriving to the lab and asking to use the technology. So some for research, some for their own use. So people suffering from all sorts of issues that can be resolved with electrophysiology, and people from doing research in Europe, people doing research in North America. And very soon it became, so we started some collaborations and we got several nice grants, and but it became very quickly it became very clear that it's completely not scalable, because we cannot collaborate with every person who wants to check out or use the electrode. So that was a very big and strong motivation from my end, which of course is not necessarily something that investors would be too excited about, but this was a really big driving force from my end. And of course, in parallel, there was also pretty growing interest from different industrial partners, different companies, again, showing up almost every week, asking questions and looking for ways to collaborate. So the need was basically spelled out. There was no issue of trying and convincing people that there is a need. That was almost the other way around, that people were approaching us, expressing their enthusiasm. What was a lot more challenging was to make the business story. So yeah, thousands of people can use the technology. That's great, but yeah, so the commercial story was a lot more difficult to build, and this is something that I was basically unable to do on my own. And this was where teaming up with people that actually can do the business talk became very, very important. And so this was a very, very, this relates to what we discussed before, the fact that you have around people that have built companies, startup companies, and have raised funds and know how to do it. So framing the story into a commercial story is something that really goes well beyond the natural or the conventional academic work. And so this is something that I was completely beyond me, and I was very, very happy to have the support and help of other people. And so from that point on, basically, it's about the balance between the business story, where this technology of all the different applications and the many, many, many applications, which are the ones that can actually support a good financial story.
Yeah, that's really cool. So, okay, it was very easy in the beginning. The technology was very promising, but then the commercialization or the investment side was more difficult. So, did you guys start out selling something, and have you changed? Is it always doing what you intended it to, or has it changed or anything like this over the last few years? And how long has it been going on again?
No, the company started 1.5 years ago.
Okay.
So at the moment we're focusing on three directions. The sleep and is one, the monitoring sleep at home. The second one is sports applications, as we discussed, and the third one is a kit that any researcher or developer can use the technology for whichever application they want to check.
Okay. Very cool. Yeah. So some of these are a little bit more academic, and some of them are a little bit more clinical or more therapeutic, right?
Yeah.
Okay. Very cool. And then I wanted to talk about Rainbow Medical and Nano Retina. In your background, you have an eye, like a model of an eye. Do you want to talk about some of these retinal electrodes?
Just briefly. Actually, I'm not sure. I'll say some really, really, really general things because the company is not interested in at the moment. We better not.
As advertise or talk about potentially secret or confidential
Yeah,
things, right?
it's a really very sensitive moment. So I'll say something really, really general. And so yeah, nanoretina is a very different story because it's implantable device. It's a device that includes ASIC development and a MEMS part, which are penetrating electrodes. And it's a very complex technology. All these technologies have to be miniaturized into a 4 millimeter by 4 millimeter device that is implanted in the eye. So yeah, being part of this, and finally last year reaching the stage of clinical studies. So the implant is already has been implanted in several patients. So it's an incredible journey that I'm really, really happy that I had the opportunity to be part of.
Yeah, that's promising stuff. I mean, Second Sight kind of had some issues a while ago, so this is kind of a little bit of similar, kind of path of that, and it's really promising technology that needs to exist, honestly. So that's really fascinating stuff. Is it kind of based on the same printed
No, no,
electrodes
no,
that you had
no,
been doing?
no, 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 no. The nano retina is based on silicon technology.
Okay, yeah, the ASICs. Okay, very cool. So, what are some of the challenges, I guess, going back to the wearables sides of things? What are some of the challenges in this research, or in kind of making it more mainstream, I guess?
So I guess there are um, several sides, several. Um, I can answer this questions in several respects. So when doing research in this field, a very major challenge is, of course, the multidisciplinarity. So typically that takes many years of studying a lot of different things. So uh, it's a big load on myself, but it's a huge load on students. I guess you experienced it yourself. You basically have to learn, like in many engineering fields, but this one probably in particular, you really have to master quite a lot of different fields. And personally, my own preference has been to force students into really going into all the different related fields. So my student, Lila Hinzelberg, who did her PhD while developing this technology, she had her first degree in mathematics and bioengineering and neuroscience. And so she also worked, at least got to experience also what does it mean to fabricate these electrodes. So of course, it's not very smart to make everybody do all the different tasks involved in such projects, but it definitely is important that everybody knows and really understands the different elements associated with such technology. So it's computing, it's mathematics, it's material science, it's neuroscience, it's electrophysiology, some biology, some issues related to the skin. This is, on one level, you can think about it as a challenge, but also, of course, it's one of the nicest thing about this field because it's really, really interesting. But you need people that can really handle the situation. I've seen people that it was very, very smart people that this was just too much. So this is one thing, and of course it's not just the people, but also the lab. The lab has to have infrastructure from all these domains, and that's also pretty challenging to handle. So I think these are one big issue, at least with this project. Again, as I said, it was from the use point of view, it was very easy because we've received a lot of attention, even people from other laboratories. Almost after every presentation, people would show up, ask questions, wanted to collaborate. So that was not a challenge. But again, identifying specific applications with commercial value, this becomes again a big challenge. So it's from entirely different domain.
Yeah, exactly. And I guess that's adding to the multidisciplinarity, adding business and economics and all this kind of stuff to already the long list of things that, students or, researchers or whatever need to learn. So, but I think that's, to me, that's an advantage, that you get to learn a lot of things and you're not only limited to something like mathematics and you can learn many more things. Yael Hanein, this has been very pleasant. I've learned a lot, and I really like the work that you're doing and how you're able to, you seem very good at this, putting all these things together and all these different fields and kind of mastering them all. Is there anything that we didn't talk about that you wanted to mention?
No, on your list you had the question, what would I do with endless funding? And
yeah.
I didn't have an answer, so I'm happy we didn't go into it.
So really, you didn't think about it? Like, what would that look like? Unlimited shekels?
Yeah, just spend the time working instead of writing grants.
Yeah. Yeah, definitely. The grant writing does not seem fun. It does not look like a good use of time sometimes, but it might sharpen your thoughts sometimes. Yeah. So it could be beneficial, actually. Well, thank you so much. This has been very enjoyable.
Great. Thank you so much.
Hope you enjoyed the show and were able to learn something new, bringing together different fields in novel ways. Until next time on the Neural Implant Podcast.